We are very much used to the compass, very widely used to know the direction. A small compass needle is kept here. It is showing north here and south here. Dr. Siddharth, please correct me. I think north is in this direction because you are planetary medicine. So north is here and south is here. Now I have got this is called as coil. Let us understand, children, what is a coil. A coil is a thin copper wire is taken round and round and round and round. It's called a winding. We wind it. What is the material used? Invariably copper, many times aluminum also. The difference between ordinary copper and this is it has a continuous coating of insulation. We call it as enamel varnished wire. We also call it as winding wire. It's also called as magnet wire, super enamel wire. These are the things. And when you just loop this in this form, it's called as an electrical coil. You must know perfectly what is an electrical coil because most of the things today are dealt only with coils and coils and coils. So this is a coil. It's not necessary all coils should have this shape only. It may be rectangular, it may be square, it may be oblong, many other things. You may figure out 8 also, making two holes in that, but it should form a loop in that. It's not necessary it should be so big. It may be a very thin coil, like the voice coil of a loudspeaker. It may be a very huge coil, like a reactor, what we use in our industry and other things. So coil is a coil, it will have several turns. In this, some 600 turns are there. What we do is, this poor compass, which is very favorable to this universal magnetic field, because somewhere at this side, the south portion of the magnet of the world is there. So this is facing that. We know two dissimilar poles always they just attract each other. We'll try to create some disturbance in this coil. One of the students, please come. What this boy is doing, he's taking a cell, a battery, 1.5 plus 1.5 is 3 volts, plus is here, minus is here. He is going to connect this. The moment he has connected, the north pole is just exactly bisecting this auditorium, like this. It is in this, I think you can all see it. Now, please change the direction. Now, other thing has happened. Why? Earlier it was very obedient to this universal magnetic field. Now why it is changing? Because there must be some magnetic field here also. Because of the proximate, it is very close to this magnetic field. It is something like that. You are all obedient to your headmasters or the principals in your school. But when I take classes, you are all obedient to me because you are close to me. You are proximation. So this is more obedient here to this magnetic field than the university is forgetting. So what have we done by passing this electric current so many 600 times, the current is passing and reaching back here, the magnetic field is created. This is a very, very important experiment. What are the things we have observed in this is, any conductor carrying an electric current has a magnetic field around it. And if you want to have a concentration of the field, have many number of turns. So these many number of turns multiplied by the current that is flowing brings some strength in it and creates a magnetic field. Also, we found if the current is in this direction of the coil, the north will be towards you. If the current is in this direction, the north will be like this. These are some of the very established fundamentals, the flow of current, the direction of the field. Now, what we do is, this is called as a galvanometer. When we have passed the current in this, we could get magnetic field. Why not we introduce a magnetic field itself in this? If you introduce a magnetic field, something should happen. If something is happening, what should be? The converse, we should get some current. The current, what is the nature of the current? To see that, we have got a galvanometer. Only thing is this needle moment, you can't see from a distance. I'll show through my hands when it comes. This is our old system of teaching. Let us not forget about it. Now the speciality of this is, the zero is in the center. Whether we get current in one direction or the other also can be found. Now, will you please come that way? Oh, what is this? It is written as S. This is written as N. North and south. What may be this? Magnet. Very good. Now I will request this boy. Please come here. Why don't you sit comfortably? Baith jao. Bhojan asan. Right. Very good. Hold it. I think this gives a very good picture in TV. I mean, video is not very good. You are covered. Now, please say that. That is, so this shows a right hand deflection. And now the flux is full. Coil is not bothered, flux, it doesn't want, it only wants the rise to giving to that. Now when you pull it back, what is happening? The other thing is happening. That means from maximum flux you are coming to zero, therefore current is. So this is one of the philosophy of producing the electric current. Now instead of north, we'll take south. Okay? What should happen now? When you press it in, it is the left side. When you take it out, other. Now, with this, what I do is, I will try to rotate this. If I rotate the magnetic field, what should happen? Yes, one of you can tell me. Very good. Please give a good clap. You all have understood before me. Very good. Now we see. Please watch this thing. Can you see? North, south, north, south, north, south, north, south. It is changing. The current is going positive 0, negative 0, positive 0, negative 0. It is passing through this. And when the current changes from positive to 0 to negative to 0 to positive to 0, we call this as alternating current. Because it is alternately plus and alternately minus. So this is how, by rotating a field in a coil, alternating current can be generated. This is one method. You please keep this. Instead of rotating this, I will rotate the coil. This is another method of generating the electric current. Now, these are some wonderful experiments done by our great scientists.